All right, so we last left off with assumptions of projectile motion. This is part 2 of the kinematics presentation. So number 1, the curvature of the Earth is negligible and can be ignored. So we're assuming that the Earth is flat over the horizontal range of the projectile. Now, as you get into things like rockets and spacecraft and things like that, obviously you have to account for the curvature of the Earth. But here close to Earth, we can assume that it is flat. Effects of wind resistance are also negligible. Any object that we're going to be using as a projectile effectively negates wind resistance. So any kind of ball that you use that is round doesn't have wind resistance. Variations of gravity also is negligible and can be ignored. So even if you're on the top of a mountain or at sea level, the variation of gravity is minimal, and so we don't worry about it. So gravity is constant. These two numbers you need to keep in mind. G equals 32 feet per second squared, or G equals 9.8 meters per second squared. So depending on if you're in US or if you're in SI. So to start with, the horizontal direction represents the range or the distance total that the object travels. That's going to be your X direction. Vertical direction represents the height that the projectile reaches, or Y direction. So, horizontal direction, there is no acceleration. Therefore, A sub x is always going to equal 0. So, in this case, your Vx is going to equal your Vix. And so what that means is your x velocity is going to be the same as your initial x velocity. There's no acceleration in the horizontal. Vertical, gravity affects acceleration. It is constant and directed down. Therefore, your A sub y will always be a negative g, negative 32 feet per second, or negative 9.8 meters per second squared. So in this case, Vy equals your initial velocity of y minus gravity times time. So at the maximum height of your parabola, or the maximum height of your projectile, Vy max is going to be 0. Okay, there's no velocity once the projectile reaches its total height. And this is going to happen when the total time is in half. So the total time that the projectile is in the air, halfway through, it's always going to reach its maximum height. So T1 is total time divided by 2. The x position then is defined as x equals initial velocity of x times time plus 1/2 of x acceleration times time squared. Since the horizontal motion, though, has constant velocity and the acceleration is 0, the equation simplifies to x equals initial velocity of x times time. Y position, y equals initial velocity of y times time plus 1/2 acceleration of y times time squared. Since vertical motion is accelerated due to gravity, ay is a negative g. So the equation simplifies to y equals initial y velocity times time minus 1/2 times g, which is gravity, times time squared. So if we take this one step further, your projectile motion graph looks like this. H is height, and we know that's going to occur halfway through the projectile. R is range, and so that's going to be our total x distance. Velocity, initial x, and initial velocity. And the velocity initial y would be the hypotenuse of our right triangle. So we can use right triangle trigonometry to solve these problems. So cosine of theta is adjacent over hypotenuse, or VIX over VI. So cosine of theta, again, VIX over VI. Or, written another way, VIX equals VI cosine of theta. Sine of theta, opposite over hypotenuse, so that's the SO of SOHCAHTOA, equals initial y velocity over initial velocity. So if we rewrite this, sine theta equals initial y velocity over initial velocity, or VIY over VI. So VIY equals VI sine of theta. So when we combine the two equations, x equals VIX times t, and VIX equals VI cosine of theta, we get x equals VI cosine theta in parentheses times time. And we combine the two equations for the vertical motion, and we get y equals VI sine theta times time minus 1/2 g times time squared. So let's look at an example. A ball is fired from a device at a rate of 160 feet per second with an angle of 53 degrees to the ground. So we have our setup here. Always important to draw the graph. Find the x and y components of VI. So at the highest point, the vertex, what is the height and how much time has elapsed? What's the ball's range? How far did the ball travel horizontally? Find the x and y components of VI. So VI initial velocity equals 160 feet per second. So VIX equals VI cosine of theta. Therefore, if we do the calculations, VIX equals 96 feet per second. VIY equals VI sine of theta. And if we do the calculations, VIY equals 128 feet per second. So we'll finish this projectile motion problem in class. Thanks.